Okay, well, I hope you all are well. I'm probably not gonna, or I'm definitely not going to upload a long video today. I'm just gonna go over a few um, small thoughts that I've had. So the first one is that my next video is probably going to be about this particular review called the Testis in Immune Privilege. And one of the reasons why I want to talk about this is your body has what are referred to as immune privilege sites, where your immune system actually does not work nearly as effectively in those areas in order to protect those areas from the immune system. So an example would be, say, your eyes or your testes, or perhaps some parts of the central nervous system, although that is under contention. But why these are important sites when it comes to infection is that if if a virus or a type of um, infection pathogen is able to live and thrive in one of these immune privilege sites, then even after you have created protective antibodies and after you fought the virus in the other parts of your body, it is still possible that those viruses can basically live in low levels in those areas for quite some time, which might not necessarily be bad for you as the host, but it might be bad for whoever comes into contact with those infected areas, because then the virus has gone from an immunoprotected area of the original host and then is reinfecting, or not reinfecting, but starting its infection in a completely different person. And then that's going to, if they're naive to the pathogen, then they're going to have to go through the entire sickness cycle. Anyways, so what would be important to know is if if say this coronavirus lives inside uh, the testes and is able to duplicate while in the um, seminiferous tubes and all those germ cells and all that stuff, then you as the host might fare very well in that it is only going to be in your testes. Granted, there could be some swelling, um, scarring, and perhaps some infertility related issues that are associated with that. But as far as you dying, that's not going to be the case. But it could end up hurting someone you end up having intimate relationships with, especially if they are naive to the virus. So that is one thing that could happen. The other thing that could happen is, say, for instance, Ebola. A lot of people who had recovered from Ebola, some of the Ebola was able to get into their eyes, and even though they had recovered from Ebola, the virus was still in their eyes for a significant period of time, and a few people ended up uh, getting damage to their eyes due to the fact that the virus was still technically there. Okay, so one of the things that some virologists and some pathologists are worried about is if the SARS-2 coronavirus is able to live happily in the testes, and we do know that testicular tissue has very high expressions of uh, ACE2 receptors, so they might be particularly vulnerable to infection. Um, and I should also mention that for other serious coronaviruses, the swelling of the testicles has been noted in not just humans for MERS and SARS. I need to look back at the original SARS, but definitely MERS. And then the coronaviruses of a lot of animal models, they sometimes have orchitis or swelling of the testicles. So it's just something that we all need to be considerate of. So that is what I'm going to be talking about, hopefully tomorrow. Today, I want to have just a short conversation about the pre-peer reviewed paper that we spoke about yesterday, where They had gone through, they did a longitudinal study of coronaviruses in 10 people over the course of 30 years. And they had a bunch of samples, blood samples from these people to detect their antibody levels for the other four coronaviruses. And what they had done with those old samples was test to see if if they generated antibodies that were cross-reactive with the spike, uh, or not the spike, but the envelope protein of SARS-CoV-2. And it turns out that they did end up getting spikes of antibodies that were reactive to SARS-CoV-2. So what can this tell you? This can tell you that there is some cross-reactivity of antibodies between the coronaviruses, um, and we expected that. But what I didn't expect was that it took a combination, or how do I phrase that? If someone was unlucky enough to get infected with two different species of coronavirus in a short period of time, so that they had neutralizing antibodies for two different coronaviruses, and I believe they had to be coronaviruses that were in different genuses. So one had to be an alpha coronavirus, the other had to be a beta coronavirus. And remember, there are four normal human coronaviruses, so it had to be there's two species in each genus, and they said that there was one from one gosh, there was one species from the alpha coronavirus and there's one species from the beta coronavirus, where if someone got infected with both of those in a short period of time, they would have showed up as being resistant or being producing of antibodies against SARS-CoV-2. So what can this tell you? This could tell you that perhaps the antibody studies, our false positive rates need to account for the differences in the other, or how do I phrase that? They need to account for the variability of the normal human coronavirus infections of those areas. So I'm just running through just a thought experiment right now. If you live in, say, a big city where you're coming into contact with a lot of people at all periods or at all times, what is very likely is that you are going to get infected with more normal human coronaviruses than the average person, right? So if I'm living a hermit lifestyle, I'll probably still get infected with these coronaviruses multiple times, but the normal human coronaviruses multiple times, but the number of opportunities for me to get that reinfection is much less. And due to this, I will probably have more spacing in between my coronavirus infections. And so I might not be producing high levels of antibodies for two different species of coronavirus at the same time. But if I live in a city, especially a city that has public transportation that I use all the time, um, as driving in the city sucks, then I will probably be always expressing high levels of normal human coronavirus antibodies, right? And so this is a predicament if we want to start testing for antibodies against SARS-CoV-2, because the people in the countryside, they might have a baseline or a base false positive rate that is here. But if you do that, use those same antibody tests in the city, then it might be a completely different baseline. It might be a completely different false positive rate, right? So these people in New York City might be testing positive for SARS coronavirus by at a higher rate, at a higher false positive rate than someone in the countryside, just because they are exposed to more other coronaviruses and multiple other coronaviruses simultaneously, right? So this is my concern is that we cannot be trusting the manufacturers of these antibody tests for um, we can't be trusting their false positive and their false negative rates. We just can't, because I shouldn't say that we shouldn't. We should put some trust into them, but we should acknowledge that if we do these tests, we need to do a correction for the false positive rate of that particular population density. Okay. So when we are giving these antibody or doing these antibody studies, we should also be doing antibody studies on the other four coronaviruses, because if the other four coronaviruses have elevated levels of antibodies, then there could be a higher bleed over rate into creating an antibody against SARS-CoV-2. And so this is one reason why I'm worried is that are the people in New York, when they say that 1 out of 5 New York City um, denizens are positive for antibodies against SARS-CoV-2, are they actually? Is it actually that large of a number that is testing positive for SARS-CoV-2? Or is it that they have more people who are infected with other coronaviruses and multiple other coronaviruses? So that's just something that I want to address. And I would hope that if they test for antibodies positively, then it truly is a positive test that they are creating these protective antibodies against SARS-CoV-2. But um, I also hope that they are antibodies that are not creating autoimmune disorders as well. So with that, I am going to, and I'm going to show that other paper. Oh, I exited out already, so I can't. Um, but that was the medRxiv paper that I had listed in episode 13. So if you want, you can go back to that video and reread it with me. But that is just something, an epiphany that came to me, that we really need to be vigilant about those false positive rates, because all the antibody studies I've seen have been pretty shoddy at giving giving me that information so that I can look on the data and glean some confidence out of it. Anyways, with that, thanks for watching for these 13 minutes. So you have a good one and enjoy the weekend.